In this video, we're going to cover 2.4 Organisation and Structure of Data. First part is file design, and there are three key definitions that we need to know. First one is field, which is where characters are grouped together to form fields. Data held about a person may include fields such as surname, date of birth, address. A record is a collection of related fields. All the information held about one person or an item is held in something called a record. Lastly, a file is just a collection of related records or data. It contains a file name, which can be used to access that data later on. And for example, a stock file will contain a record for each item of stock. A payroll file will contain a record for each employee, and so on. Fixed length records have the same number of bytes in each record or field, which makes it easier to program because storage space can be calculated, as we know exactly how long those records are going to be. It's quicker to process as the start and end locations are known. We can truncate data into a fixed size, so we can take gender, date of birth, and put them into more specific formats. The downside is it wastes storage space, as fields have blank spaces where records aren't being filled. And examples of fixed length records could include gender, date of birth, and phone numbers. Variable length records have a different number of bytes in each field or record. It's difficult to calculate how much storage space is required. They're slower to process as the start and end locations have to be calculated at runtime. Examples of variable records could be name and email addresses. Computers need to allocate memory when storing records, so we need to set up the width of the file where the units are stored in bytes, and different data takes up different amounts of memory. Fixed length records, we can estimate these by multiplying the number of bytes in each record by the number of records, and then we add 10% on for any metadata. Variable length records, we take the average record size and multiply it by the number of records, and again add 10% on for the metadata. If we go into an exam question, we can estimate these by multiplying the number of bytes in each record by the number of records. You can pause here to read the exam question and then press play when you're ready to hear how we would work it out. In a fixed length format, the maximum length of any word is 22 letters. That's what it says in the question, and there are 6,000 words to be stored. So we take 6,000, multiply it by 22 to get 132,000, and then you need to convert your answer into kilobytes. In a variable length record, again, we take the average record size and multiply that by the number of records. Again, you can pause to read the question again. In a variable length format, it says that the average word length is 7 letters. We're going to add 1 to the end of that for the end of record operator. So we do 6,000 multiplied by 8 to give us 48,000 bytes. Again, convert your answer into kilobytes to get the final answer. When it comes to searching or updating in a fixed length records, the position of any record can be calculated by multiplying the length by the sequence number, and then we can conduct a binary search to locate that fixed length record in a sequential file. This can be updated quickly without affecting other records in the file because there should be empty space in the record to allocate increase in data size. In a variable length record, you have to use a slow linear search because you don't know how big those records are going to be. When it's updated, the record size changes, so the file has to be rebuilt, and we insert the updated record at the correct place in the sequence. This format is not ideal for searching and sorting if that's a priority in your file. File access can be accessed in 3 ways: read, write, and append. Read allows us to read the data in the file. Write lets us empty the file and write new data, and append allows us to add on to existing data. The second part is file organization, and this can be split into 2 parts called master file and transaction file. In the master file, data is held sequentially in key field order, and this holds descriptive data, which is the data that's going to be processed, and it also holds the resultant data once it has been processed. It contains long-term data records which would not normally change or are updated periodically. For example, this could be customer details for an electric company. In a transaction file, data is held serially in temporal order, meaning the order that it was collected. It contains the changes that are supposed to be made to the data in the master file, and this could be customer meter readings for an electric company. We can also organise files sequentially, serially, index sequential files, or multi-level indexing. In a sequential file, records are stored in order, usually based on the primary key fields, and to add to a sequential file, we have to make a new file, copy the old file until an insertion is required, and then insert the new records and continue copying the rest of the file. In a serial file, they are not stored in any order, it's just stored in the order of arrival, and we can just add data by appending it to the end of the file. In an index sequential file, records are stored in key order in the file. They are normally organised into blocks, and an index allows data to be accessed directly. This is advantageous because it means we have faster access. We can use the index to access required data directly. In multi-level indexing, there is a main index containing the location of the next index, and this can spread over several levels, with the last index containing the physical address of the record. And then an index is just used here to improve access time to records. When we want to update and add records to files in a sequential file, like I said, we have to make a new file, copy the old file until that insertion is required, and then insert the new records and keep copying the rest of the file. If we have multiple records to be updated or added, this should be sorted before the process takes place to avoid having to do multiple updates. In a serial file, we just append the data to the end of the file. When we want to delete records from files in a sequential file, it's the same process as updating, but where a deletion is required, we don't copy the records and we continue to the end of the file. And again, if we have multiple records to be deleted, this should be sorted first to avoid multiple updates. Deleting from a serial file is the same process as deleting from a sequential file. Updating and adding records to an indexed sequential file. I'm going to do this through the use of an exam question. It says explain how new customer records 3892 and 3893 are to be added to the system, mentioning the creation and linking of any necessary index or data blocks. Firstly, we create a second level index with entries from 3000 to 3900, and we link to a pointer from 3000 in the first level index. We then create a third level index with entries from 3800 to 3890, and we link to the pointer from 3800 in the second level index. We then create a data block for the records 3890 to 3899, and then we store the two records in sequential order within that data block. A direct access file or a random access file has records that are stored and retrieved according to either their disk address or their position within a file. The new location for the record is calculated using a hashing algorithm, which is usually carried out on key field data or some other mandatory item. Data collisions occur when two items are hashed to the same location, and in this case, there needs to be an overflow area where the latest data is stored. A flag gets pointed to that location, so when you're searching, you know to search the overflow area. As the overflow area gets larger, access will become slower. And just a quick note that overflow area is stored and searched using a linear method. Once the overflow area gets too large, access becomes slow. We need to create a new hashing algorithm and then create a larger file to avoid having slow access times. Existing records accessed the same way as they are stored. You hash the key field data, and that will give you the location of where the data is. In a progressive overflow area, if the memory location for storing a record is in use, the record is stored in the next empty location in the sequence. If it reaches the end of the file, the search continues from the beginning of the main file. This means that records are stored closer to the location, so the access is faster. Less storage space is needed because you don't have an extra file. However, the main file has a fixed capacity, so the storage of further records may be prevented. Brief recap on collisions. It's just when two data items are hashed to the same location. When we're comparing hashing functions, the effectiveness is compared differently to a standard algorithm. The key thing in a hashing function for file organization is the number of collisions that occur. The efficiency of any random access file is based on how many records get stored in the same block, and to compare the functions, you must run real data. The number of collisions is directly relatable to the size and spread of the data set. Fragmentation. So over time, the file systems fill up, then file changes may result in blocks no longer being contiguous, as they may not fit back into the space that was vacated. This means files are then stored on different parts of the disk, slowing down access. You may need to run defragmentation, which consolidates data on a disk, moving all parts of files to an empty, contiguous area. Now that we've covered the two areas of organization and structured data, I want to pick up two exam questions that kind of highlight how we should answer these questions in an exam. Here is the first exam question. I would like you to pause here and have a go at answering this question, and when you have finished, press play on the video to see how it should be answered. Here is a model example of an answer. The physical location of a record is calculated using a hashing algorithm. This is usually carried out on data in the key field. When two data items are hashed to the same location, a collision occurs. If this happens, there needs to be an overflow area where the data is stored. As the overflow area becomes large, access times will slow down. Therefore, a new hashing algorithm would be required and a larger file would be needed. On the bottom right is the mark scheme. You can see where marks have been awarded. You are awarded 1 mark for each bullet point. I have ticked where the marks are corresponding to the mark scheme. Again, you can pause here and have a look to see where those marks are obtained. Question number 2. Describe the terms master file and transaction file and give an example of how these files are used. Again, you can pause here to have a go at the question and press play once you've finished answering the question. A master file stores data sequentially in key field order. It stores descriptive data, which is the actual data that is processed, and holds the resultant data after it has been processed. An example of this would be customer details for an electric company. Transaction files store the transactions. These are the changes that are supposed to be made in the master file. Data is held in temporal order, which is the order it arrived in. An example of a transaction file would be customer meter readings for an electric company. Again, on the bottom right is the mark scheme. You're awarded 1 mark for each point on the mark scheme, making sure you've given a suitable example, which ideally should be the 2 that are given in the mark scheme. Again, I have ticked where the marks are, and you can see where the marks have been obtained by looking at the mark scheme.